So hello everyone, and today we will be seeing one of the very easiest problem from LeetCode. It says contains duplicate. The problem is very simple, that we are given an integer array nums and we want to return true if a value appears at least twice in an array, and return false if every element is a distinct. So here you can see within example 1 appears twice and hence the output is 2, whereas in the example 2 nothing appears, everything is distinct and it is false. Example 3 we directly see at the first glance itself it is true. So there are multiple ways to solve this. Again, let me take you with an example, and then upon how we can solve this one out. Only if I can go ahead. Oh, okay. Let's take an example over here in such a way, like let's say 1, 2, 3, 4, and you see in the end I'll attach 1, which is the repeating thing. There are multiple ways to solve this. One is the brute force way. Brute force, which will take O of n square, which will do entire possibility. So you will consider 1, and for the rest of array check whether 1 exists or not. Take 2, check the rest of array 2 exists or not, and same goes with 3 and same goes with 4. So for each element of n elements, for each element of n elements, I am checking n minus 1 times. Then it will give me like O of n square time complexity. I don't want that. Is there any alternate method? Yes, you can sort it out. You can sort it out and you can say just, hey, I would sort this, and sorting, you know that sorting takes n into log n time complexity, and that's the reason once it is sorted, you know, the array transforms something like from this to this, and you know, if anything is repeating it will occur consecutively. So I just need to check if I'm standing at I is equal to 0, I just need to check I plus 1. If 2 was repeating, then I just need to check 1 if I'm standing at index 1, check the next one. That's it. But again, it is sorting. It is not very efficient way. Next is using a set. This is the most good way, optimal way I could say, where we can have O of n time complexity. But here the first time we are using O of n space complexity as well. That means we are saying that, hey, do not treat just this as an array, but treat it as a set. You may go for a hash set or you may map it, anything works. But yeah, what will happen with this? You will generate each unique copy with that element. So you know that one is occurring, and I will store it in a set. Next time I'm checking whether something exists within a set or not, and that's it, I want it written. There might be mathematically good solutions, such that if in this solution, let me craft it down, math. This is one another approach, advanced approach, which I would mention that, hey, it's not required right now because it has some of its limitations. What are those limitations? Let's see. What was the problem with set? The problem was set uses O of n space complexity. We don't want that space complexity. We wanted to do it in O of 1 space complexity. So what we can do? We can directly go ahead. We can use this array itself with its indexing as this, like this. It has indexing, and you can say that, hey, if I'm seeing 1, I'll just mark index 1 at minus position, and next I'm seeing 2, index 2 at minus position, 3 at minus position, 4 mod it down, 1 at minus position. I'm again facing 1, okay, 1, that means I wanted to mark 2 at minus position, but guess what, 2 is already minus. This was a very brief explanation, but if you want to detail how you can do these things, you can click the video on your upside on the card here somewhere, and you can get an understanding how we can do that. But that obviously has a limitation. What if my array size looks like 1, 2, 99, 1000 and -2, -1? Okay, in this case you don't know, you don't have any chance, because obviously 99 and 1000 goes beyond the size of array. -1, again, it is a negative number, you cannot go minus negative indexing. So the only thing remains with us is use a set approach. So what I will do over here is I'll just return, okay, I have already done it, but I'll just return the length of set, length of what you say, num, if it is not equal to length of set of nums. So what I'll count for the nums when it is converted into set, if it is not equal to original nums, that means it is a duplicate, and I don't want to send true here, I would send false, and if it is not equal, again it is true. So let's check this once. It is accepted with sample test cases. Let me try to submit this one, and I think it is submitted. Let me minimize this one. How could I minimize this? Oopsies. I guess oh, Mac is yeah, it is accepted. And yeah, this was about it. It has accepted, beats 29%, and you can see that the most optimal solution you can see over here is nothing but doing the same. Okay, this is my code, right? So the most optimal code over here is doing the same thing, taking the nums and taking the set of nums. Both of them carries often time complexity, and space complexity is very minimal because I'm runtime taking the space complexity and runtime evading it as well. If I'm not using the set, that means it is ready for garbage collection. So you can argue it's arguable, but yeah, it consumes often space which is disposable. So that was all about it. It was very trivial problem, but it was good to solve such kind of problems as well. For more such content, click the video on your right, and I'll see you in the next one.